So in this question, we're asked to find the first terms in ascending powers of the binomial expansion of 1 plus 8x all to the power of a half. And we're told to give each term in its simplest form, and this is for 3 marks. So we're first going to have a think about the general formula. So we know that if we have 1 plus y to the power of n, we will have this for our general formula. So we'll have 1 plus n multiplied by y over 1 factorial plus n multiplied by n minus 1 multiplied by y squared over 2 factorial, etc. So now we need to think, how does this apply to our case? So we have 1 plus 8x all to the power of a half. So then we can say our y is going to be equal to 8x, and then our n is going to be equal to 1 over 2. So what we can now do is we can substitute 8x and a half into this general formula, and then that's going to give us the expansion of 1 plus 8x to the power of a half, and that'll be the first 4 terms. So therefore 1 plus 8x to the power of a half is going to equal 1 plus n multiplied by y, so that's 1 over 2 multiplied by 8x, and then we divide that by 1 factorial, and then we add on 1 half multiplied by a half minus 1. We multiply that by 8x all squared. So we've got to remember we're going to square not only the x but the 8 as well. And then this time we're going to divide that by 2 factorial. And then for the final term, it's going to be 1 half multiplied by a half minus 1. And then we multiply that by a half minus 2. Then we multiply it by y cubed. So for us, that is going to be 8x all cubed. And then we divide all of this by 3 factorial. And then we do the plus dot dot dot, because we know that this expansion will go on for more than this. So then all that's left for us to do is we can simplify this. So our 1, can't simplify that anymore. Then we have a half multiplied by 8, so that leaves us with 4x. Then we can put this into our calculator here just to do the simplification. So we'll have a half multiplied by negative a half multiplied by 64. So that's going to be equal to negative 8, and then we have x squared, negative 8 x squared, and then doing the same for our last term, that leaves us with positive 32, and we have x cubed. And we also have the additional terms, but we only need the first 4, so that is us completed this expansion here. And we'll just write that back out there. And that's us completing this question. So we know that the expansion of 1 plus 8x all to the power of a half, the binomial expansion of this is going to be 1 plus 4x minus 8x squared plus 32x cubed. This question was worth 3 marks, and we receive our first mark for having an understanding and attempting the binomial expansion with n equals 1 half, and in our case y equals 8x. So we'll give our first mark here. We'll then receive our second mark for having the correct unsimplified expression. So we receive that here, and then we receive the third and final mark for having the correct final answer. Then taking a look at part B of this question, we're asked to explain how you could use x equal to 1 over 32 in the expansion to find an approximation for the square root of 5. And we're told there is no need to carry out the calculation. So the first step, what we're going to do, if we're not going to do the calculation, but we're just going to write out what we would do. So if we substitute in x equals 1 over 32 into 1 plus 8x to the power of a half, this is going to give us 5 over root 2. So I'll just note that down. So I'm recalling the question, we were asked, we want to find the square root of 5. We want to find an approximation for that. So what we can then do is we can take our expansion, so what we worked out in part A, so 1 plus 4x minus 8x squared plus 32x cubed, if we take that and then substitute in x equals 1 over 32, we then know we can multiply it by 2, and that will give us our approximation. And why do we multiply it by 2? Because putting this in to here, we have root 5 over 2. So if we multiply by 2, we'll be left with root 5. So just writing this down, we should then substitute in x equals 1 over 32 into 1 plus 4x minus 8x cubed plus 32x cubed, and then we multiply by 2. We've therefore completed this question, and we get 1 mark for each bullet point we have here. So we get our first mark for explaining about this substituting into 1 plus 8x to the power of a half, and then we get our second mark for substituting x equals 1 over 32 into our binomial expansion. So in this question, we're told by taking logarithms of both sides to solve the equation 4 to the power of 3p minus 1 is equal to 5 to the power of 210. And we're asked to give the value of p to 1 decimal place. So we're hinted at in the question that we're to take logarithms of both sides. So we'll go ahead and do that to begin. So we know that we can take logarithms of both sides, and then this is going to leave us with log of 4 to the power of 3p minus 1. And we know that that's going to be equal to log 5 to the power of 210. So then what we can do now is we can use log laws. So I'm going to note down the log law that we're going to use. But if we have log of a to the power of b, then using the log law, we can say that b log of a is the same as log of a to the power of b. So therefore, in our case, we can take 3p minus 1 down in front of the log and 210 down in front of the log. So therefore, we've got 3p minus 1, lots of log of 4, and that's going to be equal to 210 lots of log 5. So what do we want to do again? We want to find p, so now we can rearrange this equation and try and isolate p. So therefore, we can divide both sides by log of 4, and we're going to have that 3p minus 1 is going to be equal to 210 lots of log of 5. And then we divide that by log of 4. And then the next thing we can do, we can add 1 to both sides, and then this will give us as follows. We'll have that 3p is going to be equal to 210 log 5 over log 4, add 1. But first we're going to put this term into our calculator, and this comes out as 243.80245. Now we want to add 1 to that, and that's going to leave us with 244.80245. And then to get p on its own, we want to divide everything by 3. So therefore, putting this into our calculator, that number divided by 3 is going to leave us with p is equal to 81.6008, and so on. So therefore, we can conclude that to 1 decimal place, p is equal to 81.6. I'll just put in 1 decimal place there, and we'll underline our answer, and we've completed this question. So this question was worth 3 marks, and we receive our first mark for knowing to take logs of both sides and using the first power log law. So that's at this point here when we take our powers down to in front of the log. We then receive our second mark for having an equation in terms of p and knowing how to carry it out. So we'll give ourselves this mark at this stage here, and then we receive the third and final mark for concluding with the correct answer of p is equal to 81.6, and we remember to round to 1 decimal place. So in this question, we're told that relative to a fixed origin O, point A has position vector 2i plus 5j minus 6k, and point B has position vector 3i minus 3j minus 4k, and thirdly, point C has position vector 2i minus 16j plus 4k. And for 2 marks, what we're asked to do is to find AB. So we can begin by saying we know that AB is going to be found by doing the position vector B and subtracting the position vector A. So we just note down here in column vector form, I think it's quite a good way to add and subtract vectors doing it with their column vectors, because it's quite easy to kind of see each direction as their own kind of calculation. So we have that A is 2, 5, and minus 6, and B is equal to 3, minus 3, and minus 4. So therefore, we can say that the vector AB is going to be equal to our vector B minus our vector A. So we'll have 3, minus 3, and minus 4. We put that in brackets, and then we're going to subtract A, which is 2, 5, and negative 6. So then now we just do the subtraction of each line effectively. So we're going to have 3 minus 2, which is equal to 1. We're going to have minus 3 minus 5, which is equal to minus 8. Then we're going to have negative 4, take away negative 6. So that's the same as negative 4 add 6, so that's equal to 2. So therefore, we can conclude that the vector AB, and we'll write it back in the form they give us in the question. So AB is going to be equal to I minus 8 lots in the j direction, and then plus 2k. And that's us completed this question. It was worth 2 marks. We receive our first mark for knowing how to do the calculation and substituting in the vectors correctly, as you can see we did here, and then we receive the second mark for having the correct final answer. So then in part B of this question, we're asked to show that the quadrilateral OABC is a trapezium, and we're asked to give a reason for our answer. So we first note down, we remember from part A that we've worked out that the vector AB is going to be 1, negative 8, 2, and then we know that OC, which is just the position vector C, is going to be 2, negative 16, and 4. And what do we notice about these? Well, if we multiply 1 by 2, we get 2. If we multiply negative 8 by 2, we get negative 16. And if we multiply 2 by 2, we get 4. So therefore, an observation that we make is that the vector OC is going to be equal to 2 lots of AB. So you might ask, how is this relevant? So what does this mean? This means that the vector OC is parallel to the vector AB. So what does this mean? So we know that a trapezium has one pair of parallel sides. OC is parallel to AB. So therefore, we can just make the conclusion that OABC is a trapezium. So that's us completed this question. It was worth 2 marks, and we receive our first mark for identifying the fact that OC is equal to 2 lots of the vector AB, and then receive our second mark for stating the fact that this means that OC is parallel to AB, which means that OABC is a trapezium. So we pop our second mark in at this point here, and therefore we've completed this question. So in this question, we're told that the function f is defined by the following. F of x is equal to 3x minus 7 over x minus 2, where x is a real number and we know that x is not equal to 2. And in part A of this question, we're asked to find the inverse of f at 7. So f inverse is 7. The plan of attack here is going to be to attempt to find the inverse f of x and substitute in x equals 7. So therefore, what we're going to do is we're going to rewrite this as y is equal to 3x minus 7, and we divide that by x minus 2. Then our first step here is going to be to swap x and y. Then our second step is going to be to solve for y. So what we're going to then have swapping these x and y's, we're going to have that x is going to be equal to 3y minus 7, and we divide that by y minus 2. So then now we're going to solve this equation for y. So we'll start off by multiplying both sides by y minus 2. So we're going to have x multiplied by y minus 2, and that's going to be equal to 3y minus 7. And then what we can do is expand these brackets on the left hand side, and then we'll have that xy minus 2x is going to be equal to 3y minus 7. So now we're going to get all our y terms on the left hand side and our x terms on the right hand side. So we'll leave our xy on the right hand side, and then we're going to subtract 3y, and then that is going to be equal to, we add 2x to both sides, so 2x minus 7. And then we'll now take a common factor of y out on the left hand side, and that's going to be y lots of x minus 3 is equal to 2x minus 7. And then now we can divide both sides by x minus 3, and therefore this is going to leave us with, we'll have that y is going to be equal to 2x minus 7, and then we divide by x minus 3. And this, since we found the inverse, this is going to be equivalent to saying f of minus 1 of x is going to be equal to 2x minus 7 over x minus 3. So recalling the question, we wanted to find the inverse of x when x is equal to 7. So therefore, we can do this by substituting in 7 as x. So then we'll have 2 lots of 7. And we'll take away 7. And then we'll divide this by 7 minus 3. And putting this into our calculator, we get that this is equal to 7 over 4. So therefore, we can conclude that f of minus 1 is 7. F inverse of 7 is going to be equal to 7 divided by 4. And that's us completed this question. This question was worth 2 marks, and we received our first mark for having the right method and attempting to find the inverse and substituting in x equals 7. So we'll give ourselves this mark just about here, and then we receive our second mark for concluding with the correct answer. So in part B of this question, we're asked to show that f of x is equal to ax plus b over x minus 3, where a and b are integers to be found. So here we are wanting to do a composition of functions, so we'll take our function f of x and then substitute this in to our function f of x. So basically every time we see an x, so here and here, we're going to insert our whole function into that. So therefore, we'll have that f of x is going to be equal to 3 lots of f of x minus 7. And then we divide this by f of x minus 2. So what we can do 3 lots of f of x, and we know that that is going to be 3 lots of 3x minus 7, and we divide that by x minus 2. So that is going to be equal to 9x minus 21, and we divide that by x minus 2. And then 3f of x minus 7 is going to be equal to 9x minus 21, and we divide that by x minus 2, and we take away 7, and that's 7 over 1. So what we can do here, we will have 9x minus 21 minus 7x. Then we have our negative 2 times negative 7, which is going to be positive 14. And then we divide that by x minus 2 multiplied by 1, which is x minus 2. And then simplifying the top here, this is going to equal to 9 minus 7, which is 2x. Then we have negative 21 add 14, which is equal to minus 7, and we divide that by x minus 2. So that's the first part, that's the numerator of our fraction over here. And then for the denominator, we have f of x minus 2 is going to be equal to 3x minus 7, and we divide that by x minus 2, and we take away 2 over 1. And then here, multiplying out our fraction again, we'll have 3x minus 7 multiplied by 1, and then we'll subtract negative 2x, then we'll add on 2 times 2, which is 4, and we divide all of that by x minus 2. Once again, to simplify in the numerator, we'll have that is equal to x, negative 7 add 4, which is negative 3, and we'll divide that by x minus 2. So therefore, this is the denominator. And what we're going to do is take the numerator and the denominator and substitute them in here. And we know that this is going to be equal to 2x minus 7 divided by x minus 2. And then what we could do, we could have divided by x minus 3 over x minus 2. But this gets slightly messy. So we know that dividing by a fraction is going to be the same as timesing by 1 over the fraction. So therefore, if we flip this here, it's going to be the same as multiplying. So we'll multiply this by x minus 2 divided by x minus 3. Then we see here, x minus 2 will cancel with x minus 2. So therefore, this leaves us with f of x being equal to 2x minus 7 divided by x minus 3. So therefore, we can say that this is equal to ax plus b over x minus 3. And this is as required, because that's what the question asks us. So it's as required with a equal to 2, and in our case, b is going to be equal to negative 7. So part B of this question, which we just completed, was worth 3 marks, and we received our first mark for an attempt at fully substituting in 3x minus 7 over x minus 2 into f of x. And then this was having it in the correct form, so essentially this was when we did our working over here, then we substitute it back in, so we get our first mark at this point here when we substitute the values in. We then achieve our second mark for tidying things up and cancelling out our x minus 2's, and then we receive our third and final mark for rounding back to the question and stating this conclusion here and looking back at ax plus b over x minus 3, so we receive our third mark here. So in part A of this question, we're told that a car has 6 forward gears, and we're told that the fastest speed of the car in first gear is 28 kilometers per hour, and in sixth gear, it's 115 kilometers per hour. Given that the fastest speed of the car in successive gears is modeled by an arithmetic sequence, we're asked to find the fastest speed of the car in the third gear. So what do we know about arithmetic sequences? So we know that we can work out the nth term by doing a plus n minus 1 multiplied by d. So we must think, what is an? So an is going to be the nth term. What is a? A is going to be the initial or the first term. So a is the first / initial term. So in our case, that's going to be 28 kilometers per hour, as we'll let n equals 1 for that case. And what's d going to be? So d is the common difference between terms. And at this stage, we don't know what d is. So for our situation, we're going to have a equals to 28. And then we also know that the sixth term, so a6, is going to be equal to 115. So we know this as this is what happens in sixth gear. So therefore, we can say that a6, which is equal to 115, is going to be equal to a, which is 28, plus n minus 1. So n is 6, so that's going to be 6 minus 1, which is 5. But I'll just leave it as 6 minus 1 just now, multiplied by d. So what we can do now is we can rearrange this equation and solve for d. So therefore, we'll have that 5d is going to be equal to 115. Then we subtract 28 from both sides. So therefore, we'll have that d is going to be equal to 115 minus 28, and then we'll divide that by 5. And when we put this into our calculator, and this comes out as 17.4. So what can we do now? So we have a general formula. We know what a is, and we now know what d is. So we can use this value of d here, and a equals 28 to work out what the third term is going to be. So we'll write this down here. So we'll have that a3 is going to be equal to a, which is 28, plus 3 minus 1, and we multiply that by 17.4, and then putting this into our calculator, we therefore have that a3 is going to be equal to 62.8 kilometers per hour. So therefore, we can just write a statement that 62.8 kilometers per hour is the fastest speed of the car in third gear. So therefore, we've completed this question. It was worth 3 marks, and we get our first mark for working out what d was here. We then get our second mark for substituting these values in to then find A3, and then we get our third and final mark for concluding with the correct answer, which was 62.8 kilometers per hour. So we're now told, given the fastest speed of the car in successive gears is modelled by a geometric sequence, we're asked to find the fastest speed of the car in fifth gear. So we know this is going to have a similar technique to part A of this question, but we're going to be using geometric sequences. So we know that the formula for geometric sequences will be the nth term is going to be equal to a multiplied by r to the power of n minus 1. So in the same as the arithmetic sequence, we know that an is going to be the nth term. We know that a is going to be the first or initial term, but this time we have r instead of d. So we need to have a think, what is r? So r, rather than being the difference, it's going to be the common ratio between terms. So therefore, in our case, in the same as part A, we're going to have that a of 6 is going to equal to 115 kilometers per hour, and a is going to equal to 28 kilometers per hour. So therefore, using our geometric sequence formula, we can say that a of 6, which is equal to 115, is going to be equal to 28 multiplied by r, and that's going to be power to 6 minus 1, which is 5. So therefore, we can say that r to the power of 5 is going to be equal to 115 divided by 28. So therefore, we then take the fifth root of this to find r on its own. So that's going to be 115 divided by 28, all to the power of 1 over 5. And we put this into our calculator, and this comes out as 1.3265, and so on. So therefore, we've worked out what r is, so we can now try and answer the question where we're asked to find the fastest speed of the car in fifth gear. So we can use the information which we've just found, so therefore we'll say we want the fifth term, and we know this is going to be equal to 28, because that remains the same, and we multiply this by our newly found value of r, which is going to be 1.3265. And what I did, I left the value and stored it in the answer part of my calculator. So I'll just write ... to show that we've used the full decimal places, which I've not even written down there. So that's a good way to make sure your answer is accurate. And then we're going to take that to the power of 5 minus 1, which is 4. So then we put this into our calculator, and this comes out as 86.6941, and so on. So therefore, we can round this to 3 significant figures, and that's going to leave us with 86.7 kilometers per hour. And therefore, we've completed this question, and we'll just write a little concluding statement. So 86.7 kilometers per hour is the fastest speed of the car in the fifth gear. So this question was worth 3 marks, and we received our first mark for working out the value of r. We then received our second mark for knowing to substitute in this value of r and be able to find the fifth term, and that was when we got it here, and we received the third and final mark for concluding with the correct answer, which was 86.7 kilometers per hour. So in this question, we're told to express sine x plus 2 cos x in the form r multiplied by sine x plus alpha, where r and alpha are both constants, where r is positive, and we know that alpha is between 0 and pi over 2. We're told to give the exact value of r, and we're to give the value of alpha in radians to 3 decimal places. Okay, so we can first say, our first step here is going to define alpha, and we can first say, using trig identities, that r sine of x plus alpha, using our trig identities, we know that is going to be equal to r sine x cos alpha, and then we'll add on r cos x multiplied by sine of alpha. So from this, we have that sine x is equal to r sine x cos alpha, and then we also have that 2 cos of x is going to be equal to r cos x sine alpha. So from this, we can work out that our cos of alpha is going to be equal to 1. So why does this equal 1? So we can see that the coefficient in front of sine x is 1, and then we have sine x here, so that means that's our cos alpha is going to be equal to 1. And then for the sine part, in the same way, we're going to have that r sine alpha is going to be equal to the coefficient in front of the cos x, which is 2. So therefore, we can find alpha. So we know that tan alpha is going to be equal to r sine x over r cos x. So that is going to be equal to 2 over 1. And therefore, we can work out that alpha is going to be equal to the inverse of tan of 2. And we put that into our calculator, and we remember our calculator should be in radians mode, and this comes out as 1.10714, etc. So therefore, to 3 decimal places, we'll have that alpha is going to be equal to 1.107. Just write in 3 decimal places. So that's step 1 complete, and step 2, we need to find r. So how do we find r? So we have that r is going to be equal to the coefficient of sine x squared plus the coefficient of cos x squared, and then we square root that. So we're going to have that r is going to be equal to 1 squared, and then we add on 2 squared, and we square root the whole thing. So that's going to be equal to 4 plus 1, which is 5, so root 5. So therefore, to conclude, we have that alpha is equal to 1.107, and that's in radians. And then we have that r is going to be equal to the square root of 5, which is the exact value of r, which we were asked for. Just to complete this question fully, we don't have to do this, but we're just going to write out a further conclusion that sine x plus 2 cos x is going to be equal to root 5 multiplied by sine. Then we have x plus alpha, so alpha is 1.107. And there we have completed the question. This question was worth 3 marks. We receive our first mark for knowing to do tan alpha equals 2 and then working out what alpha was. So we receive our first mark just about here. We then receive our second mark for working out root 5 as r. And then receive our third mark for having the fully correct answer with alpha being equal to 1.107. So just to summarize there, this mark here was for knowing to do the right process with alpha. This mark here was for having the correct answer, and this mark here was for having root 5 correct. So then in part B of this question, we're told that the temperature, which is measured in theta degrees Celsius inside a room on a given day, is modeled by the following equation here. So we have a constant 5, and then we add on sine pi t over 12 minus 3, and add on 2 cos pi t over 12 minus 3, where t is the number of hours after midnight. So we're asked to use the equation of the model and our answer to part A to deduce the maximum temperature of the room during this day. So recall in part A, we worked out what r of sine x plus alpha was equal to, and that was coming from sine x plus 2 cos x. And what do we have here? We have sine of something plus 2 cos of something. So if we let x be equal to pi t over 12 minus 3, we can use our answer from part A. So therefore, we recall our answer for part A was, we'll just put that in brackets here, we had root 5 lots of sine, then we had x plus 1.107. So that was our answer, and we knew that that was equal to sine x plus 2 cos x. So therefore, what we can say is we can say that theta is going to be equal to 5, and then we can effectively replace all of this here with this, but this time x is going to be equal to pi t over 12 minus 3. So we'll have 5 plus root 5 of sine, and this time we'll not have x, we'll have pi t over 12 minus 3 plus our alpha, which is 1.107. So that's us now got theta into something where we only have sine x. And what do we know about sine x? We know that it will be a maximum when sine x is equal to 1. So we know it can either, when it's at its kind of end points, if you like, it's either going to be 1, 0, or -1. Remember, we're looking for the maximum temperature, so the highest value of theta. So we know if we subtract anything from 5, it's going to get smaller. So we want to add the biggest possible value to 5 that we can. And we know that this is reached when sine is equal to 1. So we'll just write that down. So we have a maximum when sine x equals 1. Therefore, we'll have that theta is going to be equal to 5 plus root 5 multiplied by 1. So we know that that is then going to be the maximum temperature. So we know that this is measured in degrees C, or we can also put this into a calculator and just rounding to 2 decimal places or 3 significant figures, 5 plus root 5 is going to be equal to 7.24 degrees centigrade, and that's the 3 significant figures. So therefore, looking back at the question, we were asked to deduce the maximum temperature of the room during the day, and we used our knowledge of trigonometry here and substituted in 1 and used our answer from part A to conclude that theta is equal to 7.24 degrees Celsius. This part of the question was worth 1 mark, and we get 1 mark for having the correct maximum temperature. So in part C of the question, we're asked to find the time of day when the maximum temperature occurs, and we're asked to give our answer to the nearest minute. So from part B of the question, we have this formula here. So we have that theta, which is the temperature, is going to be equal to 5 plus root 5 sine, then this expression here, pi t over 12 minus 3 plus 1.107. And we said that the maximum temperature occurs when sine x equals 1. So we're writing that down. We'll just say that in part B, we said the maximum temperature occurs when sine x equals 1. So what do we want to do here? So we're wanting to find the time of day. So we want to solve for t. So we know that we want to take what's inside the brackets and make it equal to the value of x, which will give us the largest temperature. So we can then say that x is going to be equal to sine -1 of 1. So the inverse of sine evaluated at 1. And we can therefore say, doing this in our calculator, that x is going to be equal to pi over 2. So therefore, from this, we can take what's in our bracket here and set it equal to pi over 2. So therefore, we have that pi t over 12 minus 3 plus 1.107 is going to be equal to pi over 2. So now what we need to do is we need to tidy this up and rearrange to find t. So therefore, what we can do, we can say that pi t over 12 is going to be equal to pi over 2, and then we will add 3 and subtract 1.107, and then what we can do, we can multiply everything by 12, so we'll just put brackets in here, pi over 2 plus 3 minus 1.107, and then as well we can divide both sides by pi, so we will put our pi in here, and then we have just cancelled that out here, so we'll cancel that out, and therefore we can put this into our calculator. And what does this give us? So we have 12 lots of pi over 2 plus 3 minus 1.107. We divide all of that by pi, and this gives us that t is equal to 13.2 hours. So looking back to the question, we were asked to find the time of day when the maximum temperature occurs. And we're asked to give our answer to the nearest minute. So yes, we have a time here and it's in hours, but we don't normally say that we don't normally work in 0.2 of an hour. So we need to convert this into minutes, as that's what we're used to. So we can say that 0.2 of an hour is equal to 0.2 multiplied by 60. And we put this into our calculator, and this comes out as 12. So we have 12 minutes. So therefore, we can say that the time is equal to 13 hours and 12 minutes. But again, we were asked to find the time of day, And we know in the question we're told that t is a number of hours after midnight. So therefore, just to finish this off, we can say that t is equal to 13 hours and 12 minutes after midnight. And therefore, we've completed this question. It was worth 3 marks, and we receive our first mark for knowing to solve for t and doing that here. We then receive our second mark for getting to the stage where we had t is equal to 13.2 hours, and then we receive our third and final mark for converting this into a time of day and saying that the time is 13 hours 12 minutes after midnight. That's where we pick up our third mark. So for 5 marks, we're shown a figure which has a sketch of a curve C with the equation y is equal to f of x, which we can see is the parabola-like shape here. And then we're also told we have a straight line, which is denoted by L. We're told that the curve C meets L at the points negative 213 and 025. And we're told that the shaded region R, which is this region here, is bounded by C and L. And we're told that f of x is a quadratic function in x, so this means it will have up to an x squared term. And then we're told that negative 213 is the minimum turning point of said quadratic function. And we're asked to use inequalities to define R. So to begin, we're going to take a look at the line L. And we know that all lines, like this line in the graph, have equations as follows. So it will be y is equal to mx plus c. So we know c is a y-intercept, and we can read this off the graph. So we know that c is equal to 25, and we know this because it's the y-intercept on graph. So then now we can use this point here to work out the gradient m. So just note that down. We'll use the point negative 213 to work out the gradient. So we'll just go negative 213, and then substituting this in, we're going to have that 13 is going to be equal to negative 2 lots of m. Then we know our y-intercept is 25, so we substitute that in, plus 25. So what does this lead to? This leads to us having the fact that 2m is going to be equal to, so we'll have 25 minus 13, which is 12. So therefore, we have that m is equal to 6, and this means that the equation of the line L is going to be y is equal to 6x plus 25. So we have the equation of L, and we now need to work out the equation of C. So we know it's going to be a quadratic, so it's going to have x squared. And we're told here, very key piece of information, that f of x is a quadratic function and that its turning point is negative 213. Since we know the turning point, we can write out the equation in completed the square format. So therefore, we have that f of x is going to equal a lots of x, and then we have x plus 2 because we always flip the coordinates of our turning point. So we have x plus 2 squared, and then we add on 13. So we need to work out a. How do we do this? Well, again, we can use the points we know to work this out. So we can use the 0.25 point. So therefore, using 0.25, we'll have that when x equals 0, y is going to equal 25, and that's going to be equal to a lots of 0 plus 2 squared, which is 4. So 4a plus 13. And what this is going to do, this is going to allow us to work out what the constant a is. So we have 25 minus 13, which is 12. So we have that 4a is equal to 12. Thus, we can say that a is going to be equal to 12 divided by 4, which is 3. So therefore, we can say that the equation of C is going to equal y is going to be equal to 3 lots of x plus 2. We square that, and then we add 13. So here we've used our knowledge of completing the square and reading turning points to be able to work out what our equation is for the line L and the curve C. So all that's left us to do now is to use an inequality to define R. So we have our two equations, but we just need to think which one is going to be above the region and which one is going to be below the region. So we can see here the line is going to be greater than the curve for all of the region R. So therefore, we can conclude that we're going to have 3 lots of x plus 2 squared plus 13 is going to be less than y, and then y is going to be less than the equation of the line L, which is 6x plus 25. So therefore, we've completed this question. It was worth 5 marks, and we receive our first mark for attempting to work out the equation of the line. So we'll give ourselves that here, and we then receive our second mark for correctly finding the equation of the line. We then receive our third mark for attempting to find the equation of the curve, and then we receive our fourth mark similarly for correctly having the equation of the curve. And we then receive our fifth and final mark for putting this into inequality form and stating the correct answer. So here in this question, we're told that a new smartphone was released by a company. And we're told that the company monitored the total number of phones sold, which is denoted by N, at time T days after the phone was released. We're told that the company observed that during this time period, the rate of increase of N was proportional to N. We're asked to use this information to write down a suitable equation for N in terms of T, and we're told that we don't need to evaluate any unknown constants in our equation, and this is for 2 marks. So we want to have an equation which is something to do with exponential growth and decay. So therefore, we can say that N, which is going to be the number of phones sold, is going to be equal to, so we're going to have a constant A, and then we're going to have an exponential term, and it is going to be in terms of kt. So this is our equation here, where A and K are both positive constants. And we'll just annotate in here, we want an equation which is to do with exponential growth. So here we pick up our first mark for knowing to have an equation of the correct form, and then we receive our second mark for having this correct answer with our constants labelled as A and K and that they are both positive. So we'll just note down that for this part here we receive 2 marks. So in this question, we're shown figure 2, and that's a sketch of the curve C with the equation y is equal to f of x, where f of x is equal to 4 lots of x squared minus 2 multiplied by e to the power of negative 2x. And what we're asked to do here, we're asked to show that f dash x is equal to 8 lots of 2 plus x minus x squared multiplied by e to the power of negative 2x. So essentially what we're being asked to do is we're to take f of x and differentiate it to reach the required answer. So how are we going to do this? So we know we have one function and we multiply it by another function. So we know we can differentiate this using the product rule. So I've already written the product rule out here. So if we have one function g of x and one function h of x, then the derivative of the overall function f of x is going to equal the derivative of g multiplied by h of x, then g of x multiplied by the derivative of h. So now for us, what we can do, we can now name our functions g and h to make things slightly easier. So if we let g of x be equal to 4 lots of x squared minus 2, and then if we let h of x be equal to e negative 2x, then we now face some differentiation, which looks slightly easier than tackling this as a whole. So then we'll have the g dash x, so the derivative of g. So then what we do is we'll multiply out the brackets. So we'll have 4x squared. What does that differentiate to? Well, it differentiates to 8x. And then we have the constant negative 8, that differentiates nothing. So the derivative of g of x is going to equal to 8 of x. And then likewise, for h of x, we'll have the derivative of h of x is going to be equal to, so we know for logarithms, we multiply it by the derivative of the power. So the derivative of negative 2x is going to be negative 2, and then the rest remains the same, so that's e to the power of negative 2x. So therefore, we can say that our function f of x, the derivative of it, is going to equal 8x multiplied by e negative 2x, and then to that we add 4 lots of x squared minus 2, and we multiply that by minus 2e negative 2x. So then simplifying this ever so slightly, this is going to be equal to, so we can keep this part on the left the same. And then this is going to turn into negative 8 because we have 4 multiplied by negative 2. And then we're going to have our e negative 2x, and then our brackets stay there, x squared minus 2. So what we can now do is we can take out a common factor of 8, and we can take out a common factor of e to the power of negative 2x. So therefore, this is still f of x, and we're going to take out our common factor of 8, and then we're going to have that is going to be, to get to this first term, we're going to have that you multiply it by x. Then for the second term, you're going to multiply by negative x squared, and then positive 2, and then we have our other common factor here, which is e to the power of negative 2x. So recalling the question, we're wanting to show that f dash x is equal to this. So we have our 8 here, so that's good. We have our e negative 2x. And then inside the brackets, we have 2, we have negative x squared, and we have x. So therefore, we can just tidy this up just into the exact form that they wanted it. So we keep our 8, and then we're going to have, like they say in the question, 2 plus x, then we minus x squared, then we multiply e by the power of negative 2x, and we write as required, as this is what the question asks us to show. So therefore, we've completed this question. It was worth 3 marks, and we received our first mark for attempting to use the product rule and then starting to differentiate. So we get 1 mark here for attempting to use the product rule, and we then get our second mark for differentiating, and we then receive our third mark for having the answer which the question asked us to show. So here in part B of the question, we're asked to find, in the simplest form, the exact coordinates of the stationary point of the curve C. So the first thing that springs to mind when we hear stationary point is that we want to set the derivative equal to 0 and then solve for x, and these will be the values of our stationary point. So I've copied down our work from part A. So this was the derivative of f. So what we're going to do is we're going to set this equal to 0. So therefore we'll have that 8 multiplied by 2 plus x minus x squared multiplied by e negative 2x is going to be equal to 0. So now we see if we divide both sides by 8, this 8 will cancel out, and then if we divide both sides by e to the power of negative 2x, it will be cancelled out here as well. So this leaves us with a quadratic. So we'll have 2 plus x minus x squared, and that's going to be equal to 0. And I'll just note down, we went from here to here by dividing by 8, and we also divided by e to negative 2x, and that was on both sides. So then the next step for us, we should probably multiply both sides of our equation by negative 1. And why do we do this? Well, this will give us an easier quadratic to solve, as the x squared term will be positive. So this means we'll have x squared minus x minus 2, and that's going to be equal to 0. So now I want to solve this. So we want a number that multiplies to negative 2 and adds to negative 1. So what numbers fit this? So if we have negative 2 and multiply it by positive 1, that gives negative 2, and negative 2 plus 1 is equal to minus 1 also, so this is good. So this means our factors are going to be negative 2 and 1. So we have therefore that x minus 2 and x plus 1 equals 0. So therefore we have that x is equal to 2 and x is equal to negative 1. So we found our x coordinates, and we now want to find the y coordinates. So we know that when x is equal to 2, y is equal to f of 2, which is going to be equal to 4 lots of 2 squared. Then we subtract 2, and then we multiply this by e to the power of negative 2 multiplied by 2. And then simplifying this a little bit further, we'll have that this is going to be 4 lots of 2 multiplied by e negative 4, which is going to be equal to 8e negative 4. And we note in the question that we're asked to give the exact coordinates, so we're not going to put this into the calculator, we're just going to leave this like this. So that's our y coordinate. And then for x equals to minus 1, we'll do the same. Y is going to equal f of minus 1, which is going to be equal to 4 lots of minus 1 squared. And we subtract 2 and multiply that by e negative 2 to negative 1. Well, this is going to be equal to 4 lots of negative 1, which is negative 4e to the power of 2. And that's equal to y also. So therefore, our coordinates are, so our first one was, the x coordinate was 2 and the y coordinate was 8e negative 4. And then secondly, we had that x was equal to negative 1. And the y coordinate, which went with this, was negative 4e to the power of 2. And therefore, we've completed this question and worked out the coordinates. Looking back at the question, this was worth 3 marks. We received our first mark for getting our 2 x values, so that was 2 and negative 1. We then received our second mark for substituting in one value of x to find a value for y. So we do that for the first time here, and then we receive our third and final mark for concluding with the correct answer and saying the coordinates are 2, 8e to negative 4 and negative 1, negative 4e squared. And they are the coordinates of our stationary points. So here in part C of the question, we're given some further information. We're given 2 new functions. We're told that g of x is going to be equal to 2 lots of f of x, and that's for x in the reals. And we know that h of x is going to be 2 lots of f of x minus 3, and that's going to be for x greater than or equal to 0. And in part C1, we're asked to find the range of g. So we have to think, what is the function g of x going to be? So it's going to be 2 lots of f of x. We know f of x here, so this means that g of x is going to be 8 lots of x squared minus 2 multiplied by e to negative 2x. Why 8? 8 comes from 2 multiplied by 4. So we need to have a think about what the range is, and the range is going to be the output of our function. So this is the values that we get on the y-axis. And we know a couple of points here. So we know this point here and this point here. That's our 2 turning points. So we need to have a think now, what values is our y-axis going to take? So we can see here, this is the minimum turning point, and this was of f in the graph. So we know that if the coordinates of f of x are ab, then the coordinates of g of x are going to be a to b. And that's because g of x is 2 lots of f of x. So therefore, we can use this to help us. So we can see here on the graph that the lower limit of the range of g of x is going to occur here, because this is the low point of the function. And what is that? We know that's the minimum stationary point. We had 2 stationary points, and they had x coordinates 2 and negative 1. So we know this is going to be the one with the x coordinate negative 1. So therefore, we know that the lower limit of the range is going to be 2 lots of the y coordinate. So therefore, we'll say that the lower limit of range, that is going to be 2 lots of negative 4e squared. And what's that going to be? That is going to be negative 8e squared. And then we need to have a think, what is the maximum, so the upper limit of the range going to be? Well, we can see it's not going to be this turning point here, and we can see that this is going to go on infinitely. So therefore, we can say the upper limit of the range is going to be infinity. So therefore, we can say that the range is as follows. It's going to be from the closed endpoint, negative 8e squared all the way to infinity. Then we look to the next part of the question. So we have question C part 2, and we have that h of x is going to be equal to 2 of f of x minus 3. So that's going to be equal to the same as g of x, but we subtract 3. So that's going to be 8 x squared minus 2, and then e negative 2x minus 3. So we first need to think, right, well, is there any further information we're told? Well, yeah, so in the question we were told that this is only valid for x greater than 0. So therefore we'll write that this is for x greater than or equal to 0. So this time we're only going to be dealing with this part of our graph here, so everything to the right hand side of the axis. And we see what is the lowest part of the y-axis going to be? It is going to be when we have the y-intercept, so when x is equal to 0. So we must first state that the lower limit of the range will be at x equals 0. So therefore we'll have that h of 0 is going to be 8 lots of minus 2 multiplied by e negative 2 times 0 minus 3. And we put this into our calculator. And what is this going to be? So we're going to have negative 16 minus 3, and that's going to be negative 19. So then we can now think about the upper limit. So what's it going to be? So we're looking at everything on the right-hand side of the y-axis. So what's the highest point on the x-axis? So what's the highest point on this y-axis? Well, it's going to be our maximum turning point. So then we can say that the upper bound will be our maximum turning point. And we need to think, why is this? And this is since this is only valid for x greater than or equal to 0. And we recall from part B, this max turning point had y value of 8e negative 4. But this time, we know that our function has been doubled and shifted by negative 3. So therefore, for the h of x function, this point will be 2 lots of 8e negative 4, and then we subtract 3. So what's this going to be equal to? This is going to be equal to 16e negative 4, take away 3. So therefore, we can conclude that the range is going to be negative 19 as the lower limit, and the upper limit is going to be 16 e to the power negative 4 take away 3. And therefore we've completed this question. Question C was worth 3 marks, and we received 1 mark for stating the range in part 1. So that's here we got that. Then in the second part of the question, we got 1 mark for identifying either the lower limit or the upper limit of the range. So we'll put our first mark in here when we identified the lower limit of it, and then we receive the 3rd mark for this question for concluding with the correct answer. So here in this question, we're asked to use the substitution x is equal to u squared plus 1 to show that the integral from 5 to 10 of 3 divided by x minus 1 multiplied by 3 plus 2 lots of the square root of x minus 1 integrated with respect to x is equal to the integral with limits from p to q of 6 over 3 plus 2u with respect to u. And we're told that p and q are positive constants to be found. So here what do we need to do? We are wanting to do integration by substitution. So how do we begin this? Well, we know that the substitution that we've been asked to do is to use x is equal to u squared plus 1. So what do we do here? Well, what we're going to do is we're going to rearrange for u, and then we're going to differentiate that, and then that will give us an expression in terms of dx, which we can then substitute back into our original expression, and then we'll aim to replace these x's here with u, which will then get into some sort of form which we're after. So therefore, we're going to say that u squared is going to be equal to x minus 1, and therefore we can say that u is going to be equal to the square root of x minus 1. And this is good because we can see here we have the square root of x minus 1, which will in just a few seconds be able to substitute in u for this. So therefore we have that du is going to be equal to this term differentiated. So we know that that is going to be equal to 1 divided by 2 lots of x minus 1, and this is with respect to x we've differentiated. So therefore we'll rearrange this to find for dx. So this is going to be dx is going to be equal to 2 lots of x minus 1 multiplied by du. So that's good. This is what we can now substitute into this equation here. But first, we can also find our new limits. So I'll just write this down here, new limits. So the limits that we have currently, 10 and 5, they are with respect to x. So we need to find them with respect to u. So we'll have that for x being equal to 5, we'll have that u is going to be equal to the square root of x minus 1. So we'll have 5 minus 1. That's going to be the square root of 4, which is going to be equal to 2. And then we're going to have for x being equal to 10, we're going to have that u is equal to the square root of 10 minus 1, and we square root that, and that is going to be equal to the square root of 9, which is equal to 3. So this is our new limits here. So I'll just annotate that in, new limits. And then what's left for us to do now? Well, we want to take all this new information that we have and substitute it back in to our original equation. So what are we going to have? We know that this is going to be equal to, so we're going to have an integral, but this time it's going to be limits from 2 to 3. And we see that we have a square root of x minus 1 here. So we can substitute this with u. And then we also know that x is equal to u squared plus 1. So we can substitute in u squared plus 1 here. So then we also know that dx is going to be equal to 2 lots of the square root of x minus 1 multiplied by du. So just writing this in purple here, these 3 bits here, that is just going to help us be able to visualize what we're about to substitute in. So we're going to have 3, and it's going to be divided by u squared plus 1, and then we take away 1, and that all stays in this bracket. And then we're going to have that is going to multiply by 3 plus 2 lots of u, and then we're going to multiply all of this by 2 lots of the square root of x minus 1, which is going to be equal to 2 lots of u, so we have 2u du. So then simplifying this fraction, we have u squared plus 1 minus 1, that is going to be equal to u squared, and then we can just tidy this up here. We can take our 2u and multiply it by 3, so we have our 2u multiplied by 3, so that's going to be equal to 6u, and here we go. So then therefore, simplifying it one step further, our limits 2 to 3 stay the same. We can then divide everything by u. So we're going to have 6, and we're going to divide that by, this is now u, lots of 3 plus 2u, and this is all with respect to u. So we now take a look back at our question. What were we being asked to find? So we were being asked to find 6 divided by u, lots of 3 plus 2u, and that's what we have here. So therefore, we have got this into the form that the question asked for. So we'll write here, this is going to be as required, and we're asked to find constants p and q. So we'll just put a little note down saying we've found this with p equal to 2 and q equal to 3. This question was worth 4 marks, and we receive our first mark for starting our substitution and getting an expression for dx. So we'll give our first mark at this stage here. We then receive our second mark for doing the full substitution into our expression for the integral. So that's at this stage here. We receive that. We then receive our third mark for working out our new limits. So that was substituting our x limits into our expression for u in terms of x, which gives us 2 new limits. And then we receive our fourth and final mark for having the answer which the question asks us for, and having a concluding statement saying that we got to the required answer. So in the next part of the question, we're asked to use algebraic integration to show that our integral from part A, so the integral of 3 divided by x minus 1 multiplied by 3 plus 2 lots of root x minus 1 integrated with respect to x from the limits 5 to 10 is equal to ln of a, where a is a rational constant to be found. So first of all, it's safe to say that we know from part A that this expression we're given in the question is going to be equal to our answer which we've shown in part A. So we have that this integral is equal to the integral of 6 over u, lots of 3 plus 2u, integrated with respect to u, with the limits from 2 to 3. So this is a good first step. So the next step for us is going to be to make use of partial fractions. So we'll just write this down here. So we have partial fractions. So therefore, forgetting about the integral for the minute, we can say that 6 divided by u lots of 3 plus 2u. So we know here we can split this up into effectively u and 3 plus 2u, so that's our two factors on the bottom. This is going to be equal to a divided by u, and then we're going to add on b divided by 3 plus 2u. So we now need to find what the constants a and b are going to be. So how are we going to do this? So we're going to multiply both sides by u lots of 3 plus 2. So therefore, this is going to leave us with the fact that 6 is going to be equal to a lots of 3 plus 2u, and then we're going to add in b lots of u. So then what we can say is if we let u equal 0, we'll have that 6 is going to be equal to 3 lots of a plus 0 lots of b. So that then means here we can say that a is going to be equal to 6 over 3, which is 2. And then if we now let u be equal to 1, we're going to have that 6 is going to be equal to, so here what do we have? So we now know that a is 2, so we're going to have 2 lots of 3 plus 2 lots of 1. So that is 3 plus 2, 5, multiplied by 2, so we're going to have that is equal to 10. And then we're going to add on b multiplied by u. U is now equal to 1, so that's going to be plus b. So then what does this leave us with? So this is going to leave us with the fact that b is going to be equal to 6 minus 10, which is equal to minus 4. So therefore, what can we say? So we can say that, well, we know what this expression is going to be equal to. So we have as follows. So we copy down our expression from above, and we've worked out that a is equal to 2 minus 4 over 3 plus 2u. So therefore, what we can do now, remember we're wanting to use integration here. So what we can do is we know that this here is equivalent to this. So then if we take the integral of it, we know that this is also going to be the equivalent of 3 and 2. So now we know how to integrate this. So we integrate with respect to u. We know that the integral of 2 over u is going to be 2 lots of ln u. So then for this second term, we are going to have, I'll just write it off to the side here. So we're going to have the integral of negative 4 multiplied by 1 over 3 plus 2u du. And what's this going to be equal to? So it's going to be equal to negative 4, and then we multiply that by ln of 3 plus 2u, and then we must also divide by 3 plus 2u differentiated, which is equal to 2. So therefore, that's going to be equal to negative 2 ln 3 plus 2u. So then we substitute this back into our expression, so that's going to be negative 2 lots of ln 3 plus 2u. And then we still have our limits to put in, so we put our brackets around this here, and we have 3 and 2. So then therefore, we'll just keep our equal sign going down, so we'll have 2 lots of ln of 3 minus 2 lots of ln of 3 plus 2 multiplied by 3, which is going to be ln 9. And we have kind of bigger brackets around here. Then we're going to subtract the same again, but with the limit 2 put in. So that's going to be 2 ln 2, and then this time that's going to be minus 2 ln of 7. So what can we do now? So we'll continue our working, and we'll just do it over here slightly to give us a little bit more room. So we can say, we know the log law. We know that if we have ln of a to the power of b, that is going to be equal to b ln of a. So if we have 2 lots of ln of 9, that's going to be equal to the same. We have 2 lots of ln of 3 squared, which is equally equivalent to, we can bring this power down here, and we'll have 2 multiplied by 2, which is 4 ln of 3. Then we have 2 ln of 3 minus 4 ln of 3, which is going to be equal to minus 2 ln of 3. So we'll have minus 2 ln of 3. Then we'll take a look at this expression on this side. So we'll multiply everything by minus 1, which is going to leave us with minus 2 ln 2, and we're going to add on 2 ln of 7. So remember, what are we looking for here? We're looking for something ln a. So we need to now use log laws to combine these. So we know that log of a plus b is equal to log ab, and we know that log of a minus b is going to be equal to log a over b. So therefore, what can we do now? Well, we can have a look at our first term, and we're going to have that this is going to be 2 ln 7, then we can do one subtraction, so we'll have 2 ln, and then let's go for 7 over 3, and then we'll still have our second term, which is 2 ln of 2. Saying the same again, we can then have that this is going to be equivalent to 2 ln of 7, and then we will have 3 multiplied by 2, and then we can simplify this further, which is going to be 2 lots of ln of 7 over 6. So remember, we were asked to give something in the form ln a, but we currently have a constant multiplied by ln a. So what can we do? From this log law here, we can bring this power up here and square everything. So that's going to be equal to saying that we've got ln lots of 7 over 6. And then we square all of that. So we square both terms, which is going to be equal to ln 49 over 36. And then that is equal to ln a, where a is equal to 49 over 36. So therefore, we've completed this question. This question was worth 6 marks, and we receive our first mark for knowing to use partial fractions and stating the values of a and b. So we received this when we stated our values for a and b, so at this stage here. We then received our second mark for having the correct partial fractions. So that was having 2 over u minus 4 over 3 plus 2u. So we received that second mark at this stage here. We then receive our third and fourth marks for firstly, knowing to integrate, and secondly, integrating correctly. So this is at this stage here when we substitute our limits in. So we're going to note down that we received 2 marks here. We then received our fifth mark for using our limits and getting to the stage using the correct method to get 2 lots of ln 7 over 6. So that was at this stage here where we got this mark, and then we receive our sixth and final mark for having the correct answer, which was ln 49 over 36. And we received that mark here. We're showing a graph here, which I've copied down here, and we can see that we have a circle C1, which has equation x squared plus y squared is equal to 100. And then we have the smaller circle, C2, which has equation x minus 15 all squared plus y squared is equal to 40. We're told that the circles meet at points A and B, and we can see that's here. So they meet there and they meet here. And we're asked to show that the angle AOB is equal to 0.635 radians, and we're asked to give this to 3 significant figures, and we're told that O is the origin. So just looking at our diagram in a bit more detail, we'll just zoom in here to this diagram, and we want to find the angle AOB. So we know that this means we're going to have a triangle between A, between O, and between B. And we know that we want to find this angle in here. So just zooming out again, we know that we want to find theta is what we want to find. So the first step to be able to do this is to work out the points A and the points B. So how are we going to do this? Well, we can take one of our equations and substitute them into our other one. So we can rearrange this first equation to have that y squared is equal to 100 minus x squared. And then what we're going to do, we will substitute this into C2. So we'll just write down, substitute this into C2. So then, just writing this down, we'll have that x minus 15 all squared. Then we have plus y squared. So we now are going to substitute this in, which is 100 minus x squared. So plus 100 minus x squared. And we see that is going to be equal to 40. So the next step here is going to be to expand these brackets. So we'll have x squared, then we'll have minus 15x, which is minus 30x. Then we'll add on negative 15 times negative 15, which is going to be 225. Then we add 100, we subtract x squared, and that is going to be equal to still 40. So in tidying this up, this is going to leave us with the fact that negative 30x is going to be equal to 40, and we subtract 225 and then subtract 100. So that is going to leave us with negative 285, and then we can just times both sides by -1, which gives us that 30x is equal to 285, so we can just take our negative signs out there, and that's going to give us the fact that x is equal to 285 divided by 30, and then putting this into a calculator, this is equal to 19 divided by 2, or in decimals, we can have that is equal to 9.5. So then what we can do, we can use this C1 equation to then work out what y is. Then we have that y squared is going to be equal to 100 minus 9.5. We square that, which is going to be equal to, so that's y squared, and it's going to be equal to 39 over 4. And then we want to work out what the y coordinate is, so we'll have to take the square root of this. So therefore, we'll have that y is going to be plus or minus the square root of 39 divided by the square root of 4, which is 2. So therefore, we can see we have one x coordinate, and this makes sense because the x value of these are the same, but then we're going to have one positive on the y-axis and one negative on the y-axis. So therefore, what we can say is that the point A is going to have coordinates 9.5, and then just so we have this, we can actually say that y is also equal to plus or minus, we put root 39 over 2 into our calculator, which is equal to 3.12. So then we say that point A is going to be the one that's above the x-axis, so it's going to be positive, so 3.12. Then on the other hand, we have the point B, which is going to be equal to 9.5. It's going to be the negative y value, which is going to be negative 3.12. So therefore, we've calculated these coordinates. So we need to have a think, what do we have just now? So we have a triangle, which is as follows. So we have, this is our angle theta in here, and we know that this is split across the origin here. And then we have that this here is going to be the radius, and we know of C1, that is going to be equal to the square root of 100, which is 10. And then we know, well, what is this going to be here? This is going to be the point from, if we look at it on our diagram, maybe that'll help to see it better. It's going to be a point from the origin to the kind of x value, so the x value that the A and B point take, so it is going to be 9.5. So therefore, so from this, we know that we can then write out a right angle triangle, which is as follows. So we have our right angle here. If we let this be the angle alpha, then we know that this is 10 and this is 9.5. So therefore, we can effectively say that we can work out alpha. We can do this in trigonometry, and then we know that alpha is going to be half of what theta is. So if we say we'll let alpha be equal to theta divided by 2, then we can solve for alpha. We know that alpha, we have that cos alpha is going to be equal to, well, we know for saw katoa, it's going to be the adjacent over the hypotenuse. So we're going to have that this is the adjacent, that is the opposite, and this is the hypotenuse. So we're going to have 9.5 divided by 10. So therefore we can take the inverse, and we have that alpha is going to be equal to cos negative 1, 9.5 over 10. And we put this into our calculator. Remember to have our calculator in radians, and this comes out as 0.31756. And then from this, what can we do? Well, we can then say, so therefore, we can now work out what theta is going to be. Theta is going to be equal to 2 lots of alpha, which is equal to 2 multiplied by 0.31756. So that we then put this into our calculator, and this is going to be equal to 0.63512 in the question. We recall that we're asked to do this to 3 significant figures. So therefore, we can say, we'll just write a little concluding statement, because in the question they refer to it as the angle AOB, So we'll do the same. So we'll put, therefore, the angle AOB is equal to, now we'll round the value to 3 significant figures, which is 0.635, and we'll write as required, as this is what the question asks for. So as required. So this question has now been completed. It was worth 4 marks, and we received our first mark for working out the x-coordinate value just here. We then received our second mark for getting the y-coordinate. We then received our third mark for doing our trigonometry, knowing to use these triangles, and for getting the fact that alpha was going to be equal to 0.31756. And we then receive our final mark for doubling this and concluding with the required answer which the question asked for. So now we can see that the region which is shown in this graph here by the faded bits, it is bounded by C1 and C2. And we are asked to find the perimeter of the shaded region, and we're asked to give our answers to 1 decimal place. So what is the perimeter? So we effectively know that the perimeter is going to be right around the edge of our shape. So normally we can work out the perimeter or the circumference of a circle, but this time we can see that we have 2 circles, but they're not full circles because we have the bits where they join up. So I'll just highlight in yellow what our perimeter is. So we'll come all the way around here, and then we'll get to this point, add on that part there, and then there we go. So that's our perimeter there. So we need to have a think. Normally we'd just work out the circumferences of the circles, but we know that we must take out the bits where the dotted line are. So we know that this part of the perimeter for that circle and this part of the perimeter for that circle. So we must think, what does this depend on? So it depends on this angle theta, and we're going to use the angle theta which we worked out here, and then we're going to work out an angle in this triangle here, which is going to help us to be able to calculate the perimeter. So I'll just draw right angled triangles in again. So we have one here, and then let's say that's our center here. We're also going to have one a bit like that. So first of all, we're going to have a look at C1. So for C1, we know that the angle theta, so we'll just label this as theta here, and then we have denoted the angle in here as beta. So we'll just annotate that a little bit better just to make sure we can all understand it. So that is beta and that is theta. So for C1, we know that theta is going to be equal to 0.635 radians. How do we know this? So we know this from part A of this question. So then how does this affect us? So we also know, we know that, and we also know that the radius is going to be 10. So therefore, we can say that the perimeter of C1, and let's denote this as P1, so therefore we'll have that P1, so the perimeter of C1 is going to be the radius 10, and we're going to multiply that by full number of radians in a circle, so we have 2 pi, and then we're going to subtract this angle theta, so 0.635, and we put this into our calculator, and this is equal to 56.48. So that's the perimeter from here all the way around to here. So what we've effectively done is we have taken the angle, so this part here, out by subtracting it from 2 pi. And why is this? We know that the circumference or perimeter formula is going to be 2 pi r. So therefore, for C2, we need to do a little bit more work. So for C2, how are we going to do this? So we have this triangle in here, so I'll just copy it out a bit bigger here just to make life a little bit easier for us. So we have our angle beta in here, and then we can also split it into 2, just like we did in the previous part of the question, and we have a right angle here, and we can say that we'll then have a sub-triangle, and this time we know, in the same way as the previous question, that this part here is going to be root 40, because that is the radius of C2. And then this dotted line here, so the dotted line, how are we going to find it? So we know that the center of this circle is going to be the point x equals 15. That's because the equation is x minus 15 all squared plus y squared is equal to 40. So therefore we know that to go from here to this point here, we already figured that out in the previous part. That was going to be equal to 9.5 because of the coordinates of A. And we know all the way to here is 15, so that leaves this distance here to be 5.5. So we have 5.5 in there. So that's 5.5. How did we get that? That is going to be 15 minus 9.5. And what are those values? So that is the center of C2 and 9.5. What is that? 9.5 is the x coordinate of A and B. So then what does this mean? So this means we can do exactly the same as we did in the previous question, but we're just going to skip out a step, and rather than multiplying everything by 2 and kind of organizing a new angle, we can just simply say this time that beta is going to be equal to 2. So we multiply it by 2 because the calculation we're about to do is just going to find the angle from here to here. So therefore we multiply it by 2. So it's going to be 2 multiplied by cos negative 1, and we're going to have 5.5, and we divide that by the square root of 40. We put all this into our calculator, and therefore we have that beta is going to be 1.03 radians. So now in the same way as we found the perimeter C1, we'll say that the perimeter of C2, let's denote it by P2. How are we going to work it out? So we're going to do it the same way. We're going to have the radius, which is root 40. Then we're going to multiply it by 2 pi, but this time subtract 1.03, put our brackets in there. We then put this into our calculator, and this is equal to 33.22. So then we can say that the total perimeter is going to be equal to P1 plus P2, and we have that is 56.48, and then we're going to add 33.22 to that. So we add these together, and we can therefore say that the total perimeter is going to be equal to 89.7. And we've therefore completed this question. It was worth 4 marks, and we achieved our first mark for working out the perimeter of C1. So that was when we said 56.48. We then received our second mark for working out this angle beta and saying that it was equal to 1.03 radians. Then likewise for C2, we receive our third mark for then calculating that it was equal to 33.2. We then receive our fourth and final mark for concluding with the correct answer, which to one decimal place was 89.7. So in this question, we're asked to show that cosec theta minus sine theta is equivalent to cos theta multiplied by cot theta. And this is for 3 marks. So what we're going to do here is we're going to take our expression, we're going to take the left-hand side of it, and we're going to use trig identities and manipulate our expression to eventually come to this term on the right-hand side. So as you can see, I've copied our left-hand side down here, and we'll now write down our first trig identity. So we know that cosec of theta is going to be equal to 1 over sine theta. So that is our first trig identity, which is going to be useful here. So we can therefore rewrite this. This is going to be equivalent to 1 divided by sine theta minus sine theta. So the next step here, what we want to do is we are going to multiply this out. So we're going to have 1 multiplied by 1, which is 1. And then we're going to subtract sine theta multiplied by sine theta, which is equal to sine squared theta. And then for the bottom of our fraction, so the denominator, we're going to have the denominator in this fraction multiplied by the denominator in this fraction, which is going to be sine theta multiplied by 1, which is going to be equal to sine theta. So then we have to think, now we've combined this into one single fraction, what's next? So we know that sine squared theta plus cos squared theta is equal to 1. So therefore we can say that 1 minus sine squared theta is going to be equal to cos squared theta. And we have this 1 minus sine theta here in our numerator. So we can then substitute this in. So we have that this expression is going to be equivalent to cos squared theta, and we divide this by sine theta. So the next thing that we're going to do, so we note that we have a cos theta term here. So we're going to just separate this and rewrite it ever so slightly. So we're then going to say that this is equivalent to cos theta, and we're going to multiply this by cos theta divided by sine theta. So going from here to here, we've not actually done any or used any identities. We've simply just kind of taken effectively split our cos theta squared into two individual ones. So then we can see we now have this cos theta here. So then the next trig identity we can use, we know that cos of theta divided by sine of theta, which is what we have here, we have that this is going to be equal to cot of theta. So therefore we can substitute this back in, and what do we have? What we have is going to be equivalent to cos of theta multiplied by cot of theta. So therefore, this is the required answer. This is what the question wanted, and we've shown that cosec of theta minus sine of theta is equivalent to cos theta multiplied by cot theta, and this is as required. So this question was worth 3 marks, and where did we pick up our 3 marks? So we receive our first mark for either stating and using the trig identity that cosec theta was equal to 1 over sine theta. We then get our second mark for substituting this in and then combining our fraction to be a single term. So that was at this stage here when we had 1 minus sine squared theta over sine theta. And then we receive our third and final mark for following through with the rest of this and coming to the correct conclusion which the question asked for. So now in part B of the question, we're asked hence or otherwise solve between 0 and 180 degrees that cosec of x minus sine of x is equal to cos x multiplied by cot 3x minus 50. So recall from part A, we know that cosec theta minus sine theta is equivalent to cos theta multiplied by cot theta. So therefore, we can use part A and we can say that cos of x multiplied by cot of x is going to be equal to, so effectively we are given here this left hand side and we know that is equal to this, and then this is good because we have a cos on either side, which means we'll be able to cancel them out. So we can say that cos of x multiplied by cot of x is going to be equal to cos of x multiplied by cot of 3x minus 50. So now what we can do, we notice that we have a cos x on this side and a cos x on this side. So we're going to divide by cos of x and we're going to divide by cos of x. So this is going to therefore leave us with the fact that cot of x is going to be equal to cot of 3x minus 50 degrees. So therefore we can see that then we're going to have the x is going to be equal to 3x minus 50 degrees. And this is just from the fact that these coefficients are the same. So we have cot on both sides. So therefore, from this, we'll just write in here that these are equal, if you like. So then we have, therefore, that x is going to be equal to 3x minus 50. So we can then solve this. We can say that, therefore, 2x is going to be equal to 50 degrees. And therefore, x is going to be equal to 25 degrees. So then we also know that since cot x has a period of 180, we'll be able to find a second solution. So how are we going to do this? So we'll just note that down. We'll say that since cot x has a period of 180, we can find a second solution. How are we going to do this? So we're going to therefore have our second solution is going to be found as follows. So we have x plus 180 is equal to 3x minus 50. So we just add our 180 here, and that's due to the period being 180. So therefore, what is this going to be? This is going to be 2x is going to be equal to 230. So therefore, x is going to be equal to 115 degrees. So therefore, we found the second solution. And then we must also take into account the solution when cos x is equal to 0. Why is this? This is because, remember, in our original term, we have a cos x. Hence, therefore, we'll have the solution when cos x is equal to 0. So we'll just note down here, there will be a third solution when cos of x is equal to 0. So therefore, we'll have that x is going to be equal to cos negative 1 of 0. And putting this into our calculator, we'll therefore have that x is going to be equal to 90 degrees. So therefore, just concluding on all of this, we'll have that x is equal to 25 degrees, x is equal to 90 degrees, and our third solution, which we found x is equal to 115 degrees. And therefore, we've completed this question. Looking back, this question was worth 5 marks. We receive our first mark for getting to the stage where we had x is equal to 3x minus 50. And we then receive our second mark for getting our first solution, which was x is equal to 25 degrees. We then receive our third mark for identifying that this will be another solution due to the period of cot x, which we get here, and then we receive our fourth mark for finding this second solution, and we then receive our fifth and final mark for knowing that there'll be this cot x equals 0 solution and having that x was equal to 90 degrees, and we've therefore completed this question. So here in this question, we're told that a sequence of numbers denoted by A1, A2, A3, and so on is defined by the following formula. So we have that the n plus 1 term is going to be equal to k multiplied by a n plus 2 all divided by a of n. And we're told that n is a natural number. This is what this n means here. And we're told that k is a constant. So this k here is a constant number. We're told that the sequence is a periodic sequence of order 3. And we're told that a1 is equal to 2. And we're asked to show that k squared plus k minus 2 is equal to 0. And we're asked to do this for 3 marks. So I've just copied our equation down here. And what do we know? So we know that a1 is equal to 2. So we first need to have a think, what is a1? So we know that this is going to be the first or the initial term. And we're told that it has a period of order 3. So this means that after every 3 items in the sequence, after every 3 numbers in the sequence, it's going to go back and repeat. So this is going to be key to helping us. So how are we going to do this? So we're going to work out what a sequence is in terms of k, and how can we do this? We can do this because we know that a1 is equal to 2. Since we have that a1 is equal to 2, we can say that a of 2 is going to be equal to k, and we're going to multiply that by a of 1, which is 2, and we add on 2, and then we divide that by 2. So what's this going to be equal to? This is going to be equal to 4k over 2, which is equal to 2k. So then we can now we have a2, so we can do the same and substitute this into our formula. So therefore, we can have a3, it is going to be equal to k, and we're going to multiply that by a2, which is 2k, and we add 2, and then again we divide by 2k. So what's this going to be? So we're going to simplify this, and we're going to have 2k squared plus 2k, then we divide all that by 2k. And then what we can do now is if we divide everything by 2k, this is going to leave us with k plus 1. And we have this because everything cancels out. This 2k and 2k cancel, which leaves us with 1. And then this 2k squared cancels with the 2k, which leaves us with k. So then what we can do, we can repeat this process again, and we can find the fourth term. So we have the a4 is going to be equal to, or we're going to have k, and we're going to multiply it by k plus 1. Then we're going to add 2, and then we're going to divide by k plus 1. So what's this going to be equal to? This is going to be equal to k lots of k plus 3, and then we're going to divide this by k plus 1. So we've used this first piece of information we've given. So we've used the a1 is equal to 2 to work out a2, then a3, and a4. But we're going to stop here. And why is this? We know that we have a periodic sequence of order 3. So what does this mean? So this means here that a4 is going to equal a1. So therefore, because of this, we know that a4 is going to be equal to a1. So we can say that a4 is equal to a1. So we had a4, it was going to be equal to k lots of k plus 3, and we divide all of that by k plus 1, and we set that equal to 2 because that was our value for a1. So then we'll rearrange this, and we'll have, so we'll first expand our bracket, so we'll have k multiplied by k, which is k squared, then we'll add on 3k, and then if we multiply both sides by this denominator here, k plus 1, we'll then have 2 lots of k plus 1, which is equal to 2k plus 2. We can then simplify this further. What does this give us? So this is going to give us k squared, and then we're going to subtract 2k from both sides. That's going to leave us with 3k minus 2k, which is k, and then we're going to subtract 2 from both sides. So there we go, minus 2, and then this is going to leave us with nothing on the other side. Then we look back to our question. What were we asked to show? We were asked to show k squared plus k minus 2 is equal to 0. We looked at what we've got here, and we have k squared plus k minus 2 is equal to 0. So we write a note in here as required, as this is what the question asked us for. So therefore, looking back, this question was worth 3 marks, and we're going to just go over where we picked up our marks. We get our first mark for using the sequence formula, the one that we're given in the question. This is a formula for a of n. And we get 1 mark for using this once with a1 equal to 2. So this is when we got to this stage here. So we've used our formula once with a1 equal to 2. We then receive our second mark for setting a4 equal to a1. So that's when we stated it just here. And then we receive our third and final mark for concluding with the correct answer, which the question asks us to show. So in part B of this question, we're asked for this sequence to explain why k is not equal to 1. So what we've got here, these are our first 4 terms of the sequence. This was from part A, where we had 2, 2k, k plus 1, and k lots of k plus 3 over k plus 1. So what we're going to do is we're going to substitute in k equals 1. So we'll just write here, for k equals 1, we have, so there is no k term here, so we'll have that a1 is going to be equal to 2. Then we substitute k equals 1 into our equation for a2, and it is going to leave us with 2 lots of 1, which is 2. And for a3, what we have, we'll have 1 plus 1, which is 2. And then for our fourth term in the sequence, we'll have 4 divided by 2, which is 2. So therefore, what we can see here, we have that all the terms are the same. And this means that the sequence no longer has a period of order 3. So just writing this down, we'll say that since all the terms are the same, the sequence no longer has a period of order 3. And this means that k cannot equal 1 for this sequence. This question was worth 1 mark, and we received our 1 mark here when we stated the conclusion that all terms were the same, and this is why for this sequence k cannot equal 1. So now in part C of this question, we're asked to find the value of our sequence from r equal to 1 all the way to 80. So we recall in part A that we had our expression k squared plus k minus 2 is equal to 0. So if we solve this for k, we take out factors of negative 1 and 2, so this is going to be k minus 1 and k plus 2. That's going to be equal to 0. So therefore, we have that k is equal to 1 and k is equal to negative 2. But we know that k equals 1, this is not a valid solution for this sequence because of part B. So I'll just note that down, and we'll just put in brackets there, part B. So therefore, we have that k is going to be equal to negative 2. So then we know from the previous part of the question that these are values of our first 4 terms. So we can now use k equal 2 and substitute these in. So therefore, what do we have? We have that a1 is equal to 2. We have that a2 is equal to negative 4. We have that a3 is going to be equal to negative 2 add 1, so negative 1. And then a4, that's going to be equal to 2. And then we know because of the period 3, this is going to continue to repeat. So I'll just highlight these here. So we know that these 3, we can annotate this in purple here. So these are going to be repeating terms. So what do we want to do again? We want to find the sum of the first 80 terms. So if we have 80 terms and we know they are going to be in threes, so what we can do is we can sum a certain number of these 3 terms, and then we may have a remainder. So how do we work this out? So if we have 80, we're going to divide this by 3 because this is the order of the periodicness. So I have 80 divided by 3. This is going to be equal to 26 0.6666, so that's 26 2/3. So this means we're going to have 26 lots of these first three terms, and then we will have one of our first term and one of our second term left over. So therefore, we can say, so what we're looking for, we're looking for the sum of our first 80 terms from r equals 1, our sequence, which is here denoted by AR. So what's this going to be? So this is going to be equal to, well, we're going to have here 26 lots of our first three terms summed. So we're going to have 26 multiplied by 2, and we subtract 4, then we subtract 1. And then we have our 2/3 of our terms left over. So that's going to be here. 2/3 is a 2 and a negative 4. So we'll then add on 2 and subtract 4. So then we put this into our calculator. What's this going to be equal to? This is going to be equal to negative 80. Therefore, we've completed the question, and we've found that the sum of the first 80 terms of our sequence is going to be negative 80. This question was worth 3 marks, and we received our first mark for deducing that the repeating terms were going to be 2, negative 4, negative 1. So that was here we got our first mark. We then received our second mark for knowing to multiply these three terms by 26, and then adding on 2 and negative 4. And then we received our third and final mark for concluding with the correct answer, which was negative 80. So here in this question, we're told that a large spherical balloon is deflating. We're told that time t seconds, the balloon has radius r centimeters and volume v centimeters cubed. And we're told that the volume of the balloon is modeled as decreasing at a constant rate. We're asked to use this model to show that dr by dt, so the change in radius with respect to time, is equal to negative k over r squared, where k is a positive constant. So what are we going to do first? So we're told that the volume of the balloon is modeled as decreasing at a constant rate. So what's this? We know this is the volume. So we're going to have the change in volume with respect to time. And that's going to be equal to, let's say, negative c, where c is a constant and it's going to be greater than 0. So just put that in brackets there. So just writing that down, we're told that we have a change in volume with respect to time, and we know it's negative since it is decreasing at a constant rate. So then what do we do now? So we can say that this equation, so we'll have that the change in volume with respect to the change in time is going to be equal to, so we can split this and we'll add in with respect to r, so we'll have the rate of change of volume with respect to radius multiplied by the change in radius with respect to time. So we know that this is equal to this because if we cancel out these dr's, we have dv by dt. So what do we know? So we know that dv by dt is equal to negative c. We do not know what dr by dt is, but we know that the volume, so this is, we're dealing with a sphere, so the volume of a sphere is going to be 4 over 3 multiplied by pi r cubed. So we can differentiate this and we can say that dv by dr, so differentiating this with respect to r, is going to be equal to 4 over 3 multiplied by 3. So that's going to be 4 multiplied by pi, and then we take 1 away from the power, r squared. So what we can do, so we have this here, and we have this here, which we can now substitute into our equation here. So therefore, we can say that negative c is going to be equal to dr by dt, and then we're going to multiply this by our new expression here, which is 4 pi r squared. So when we look back at the question, we're looking for dr by dt. So we can rearrange this to find dr by dt. So what's this going to be? So we have dr by dt is going to be equal to, so we need to divide both sides by 4 pi r squared. So it'll be negative c divided by 4 pi r squared. And then again, we look back at the question, we're asked to show that this is equal to negative k over r squared, where k is a positive constant. So what we can do is we can take everything here that's not r squared and make it into a constant and label that as k. So we'll just write then, what we're going to do is we're going to let k, which is a constant, be equal to c divided by 4 pi. And then what we can do is we can take this and substitute k into that place in our equation. Then what's this going to leave us with? It's going to leave us with dr by dt being equal to negative k. And then what do we have left on the denominator? We have r squared. And looking back at the question, this is what we were after. So we'll just put in a little comment here as required, as we've now shown the result which the question asked us for. So this question was worth 3 marks, and we receive our first mark for using the model to state that dv by dt was equal to negative c. So that was identifying that it was going to be equal to a constant. So we receive our first mark there. We then receive our second mark for getting to this stage here, but with us identifying that we could use the dv by dt was equal to negative c, and use the fact that dv by dr was equal to this expression here. And we then actually pick up this mark when we substitute these terms into our equation. And we then finally receive a third mark for concluding with the correct answer which the question asked us to show. So now in part B of the question, we're told some further information. We're told that the initial radius of the balloon is 40 centimeters. We're then told that after 5 seconds, the radius of the balloon will have halved to 20 centimeters. And then finally, we're told that the volume of the balloon continues to decrease at a constant rate until the balloon is empty. And what are we asked to do? We're asked to solve the differential equation to find a complete equation linking r and t. So we know we want to find an equation linking r and t, and we can do this by solving the differential equation we got in part A. So that was dr by dt, and we know that we can use this to get an expression of r in terms of t. So the first step here is going to be to use the technique separation of variables. So this means we'll just write this in here. So we will solve this using separation of variables. So how are we going to do this? This means we want to have our r term on the same side as our dr, and then we want to have our t term on the same side as k. So therefore, we can multiply both sides by r squared, and we'll have r squared dr, and that is going to be equal to negative k. And we multiply both sides by dt, so negative k dt. So then what we're going to do is we're then going to integrate both sides just like so. So what is this going to be? If we integrate r squared with respect to r, this is going to be, we add 1 to the power and divide by the new power. So this is going to be r cubed divided by 3, and this is going to be equal to negative kt, as that's what we get with integrating negative k with respect to t. Then we're going to add on alpha, so we'll just know alpha is a constant. That's our constant. That's our constant of integration there. So then what can we do from here? So we're given some information. We're told that the initial radius of the balloon is 40 centimeters. So therefore, when t is equal to 0, r is going to be equal to 40. So therefore, we can substitute these into this equation here. So we'll therefore have that 40 cubed divided by 3. So we're just substituting these values in. Is going to be equal to negative k multiplied by 0, which is 0. And then we have our alpha term. So therefore, we have that is equal to alpha, and we'll just put 40 cubed over 3 into our calculator. What is that going to be? That's going to be 64,000 divided by 3. So that is our constant alpha. Then we use our second piece of information. So we know that when t is going to be equal to 5, we know that r is going to be equal to 20. So therefore, this time we'll have 20 cubed, and we're going to divide that by 3. And that's going to be equal to, so we've got t is equal to 5, so then we substitute that in. That would be negative 5 multiplied by k. Then we now know what alpha is. It is 64,000, and we divide that by 3. So now all that's left for us to do now is to solve for k. So how are we going to do this? Well, what we can say is we can say that 5k is going to be equal to 56,000 divided by 3. How did we get this? We got this by adding 5k to both sides and then subtracting 20 cubed over 3 from both sides. And then we divide this then by 5 to work out what k is. And this comes out that k is going to be equal to 11,200 divided by 3. So we now have our value of k. We also have our value for alpha. And then we have our equation here. So what we can do is we can take this and substitute it back in. So then therefore this is going to leave us with the fact that r cubed over 3 is going to be equal to negative k multiplied by t. So that's going to be negative 11,200. We divide that by 3 and then multiply by t. Then we're going to add on alpha, which is equal to 64,000 divided by 3. So you can see we have a 3 here, a 3 here, and a 3 here. So if we multiply both sides by 3, this here will cancel out, and then we'll have 3 here, and they cancel out. So therefore, we'll have an expression for r cubed. So r cubed is going to be equal to 64,000. Just note that we rearrange this so we then don't have a negative to start. So it'll be 64,000 minus 11,200 lots of t. So therefore, we have completed this question as we were asked to solve the differential equation to find a complete equation linking r and t. So there was 5 marks available here, and we receive our first mark for knowing to integrate and integrating one side correctly. So we'll put this mark in at this point just about here. We then receive our second mark for integrating the second side correctly and having negative kt plus alpha, where alpha is our constant of integration. And we then receive our third mark for using the t equals 0 and r equals 40 values to work out the value of alpha, which we remember is our constant of integration. And then after this, we receive our fourth mark for then working out the value of k. That was at that point here. And then we receive our fifth and final mark for concluding with the correct answer, which was r cubed is equal to 64,000 minus 11,200 t. So now in part C of the question, we're asked to find the limitation on the values of t for which the equation in part B is valid. So we'll recall that our equation from part B is going to be r cubed is going to be equal to 64,000, and then we're going to subtract 11,200 multiplied by t. So we'll just note down there that's our equation from part B. So we need to have a think. We know this is a real life scenario, and we know that we can't have a negative radius. So we know that this model will only be valid for r greater than or equal to 0. So we can't have a negative radius. So this means we'll use this to find the limitations on the values of t where the model is valid. So what we've said here is that the model will only be valid for non-negative values of r. So we'll therefore use this fact to find the limitation on the values of t where the model is valid. So therefore we know that this equation has got to be greater than or equal to 0. So we'll have that 64,000 minus 11,200t is going to be greater than or equal to 0. So we can rearrange this. So if we then subtract 64,000 from each side and then multiply everything by minus 1 and then divide by 11,200, this is going to leave us with the fact that t is going to be less than or equal to 64,000, and then we divide this by 11,200, and that's going to be equal to 40 over 7 when we put that into our calculator. So therefore, we can say that the model will only be valid for t up to and including 40 over 7 seconds. So therefore, we've completed this question. It was worth 2 marks and we received our first mark for getting to this stage here when we had this inequality. And we then receive our second mark for concluding with this correct answer, which is that the model will only be valid for t up to and including 40 over 7 seconds. So here in this question, we're told that the curve C has the equation x squared multiplied by tan y is equal to 9, and that's for y between 0 and pi over 2 radians. And we are asked to show that dy by dx, so the derivative, is equal to negative 18x divided by x to the power of 4 plus 81. So what are we going to do here? So we want to use some type of differentiation to differentiate x where tan y is equal to 9. So how are we going to do this? We're going to have to use implicit differentiation. So we'll just write this in here. We want to use implicit differentiation to differentiate x where tan y is equal to 9. Why do we need to use this special type of differentiation? This is because we want to differentiate something which has x squared and also a tan y term. So we have more than one variable. So how are we going to do this? So we know we need to use the product rule. So we know that if we have a function which is composed of one function multiplied by another function, then we can use this formula here to work out the derivative. So therefore, we can say that we are going to have x squared. What is it going to differentiate to? It is going to differentiate to 2x. And then what is tan of y going to differentiate to? Well, that's going to differentiate to sec squared y. And since we're dealing with dy by dx here, we need to then put a dy by dx in here, just to make sure we account for the fact that we're looking for dy by dx, but this has been differentiated with respect to y. So therefore, we can now use the product rule, and we can say that we have 2x, and we're going to multiply it by tan y, and then we're going to add that to x squared multiplied by sec squared y. Then we multiply that by dy by dx, and that's because we're differentiating implicitly. And then what's this going to be equal to? Well, we have that it was equal to 9. What does 9 differentiate to? It differentiates to nothing, so we put 0 in here. So what are we going to do now? So we're going to have to rearrange this equation to give us an expression for dy by dx. But if we look back at what we're aiming for, it's an expression that on this right-hand side is just in terms of x, so there's no y's. But we have tan y and we have sec squared y, so we need to now manipulate what we have here to get rid of the y's and to just have x. So how are we going to do this? So we can use the trig identity. So we'll just write down what are we going to use. So we're going to use the fact that sec squared y is going to be equal to 1 plus tan squared y. But at this point, this doesn't help us as such. What we can use additionally, we have that x squared tan y is equal to 9. So we can rewrite tan y in terms of x. So we have that tan of y is going to be equal to, well, how do we rearrange this? So we're going to divide 9 by x squared. So therefore, what does this mean? We want tan squared y. So tan squared y is going to be equal to this right-hand side squared, which is going to be 81 divided by x to the power of 4. So this expression that we have here is going to be vital to helping us move forward with this question. So therefore, we can now take this expression and substitute this in. And this helps us because we now have an expression for our y term, but in terms of x. So this is good. So what are we going to do now? We take this expression down, and our 2x will stay the same. And we're going to multiply it by tan y, and that's now equal to 9 over x squared. So we have 9, and we divide that by x squared. And then what we're going to do, we're going to add on, our x squared stays the same. And then this time, rather than having sec squared y, we're going to have 1 plus tan squared y, which is equal to 1 plus 81 over x to the power of 4. So I'll just put our brackets in there. So we have 1, then we add on 81 divided by x to the power of 4. And of course, we must still have our dy by dx. And this is all still going to be equal to 0. So now, the plan of action is going to be to simplify this and solve for dy by dx. And this should get us an expression which is in terms of x only. So therefore, just simplifying this left-hand side, we have 2x multiplied by 9 over x squared. That's going to be equal to 18 over x. And then we're going to just keep this as it is. So we'll have x squared lots of 1 plus 81 over x to the power of 4. And we still have our dy by dx. And that is equal to 0. And now we are going to subtract 18 over x from both sides. So therefore, we're going to have that x squared multiplied by 1 plus 81 over x to the power of 4. And of course, dy by dx, that is going to be equal to negative 18 over x. So what can we do now? Well, we're going to then divide both sides by this term here, and that will leave dy by dx on its own. So therefore, just moving along this way, we'll then have that dy by dx is going to be equal to, we'll have negative 18 over x, and then this whole thing is going to be divided by x squared, and I'm going to multiply that by 1 plus 81 over x to the power of 4. And now what we need to do is we have an expression which is beginning to look a little bit similar to what we need here, We can see we have negative 18x on the top. So what we need to do is we need to then simplify this into what the question asked for. So how are we going to do this? So we can rearrange this and get rid of this x term by bringing it down here, and that is going to give us negative 18, and then we divide by x multiplied by x squared, which is x cubed, and we multiply that by 1 plus 81 over x to the power of 4. So then what's our next step from here going to be? If we just take this denominator and work on it separately, so we have x cubed multiplied by 1 plus 81 over x to the power of 4. We can see that this is going to be equal to x cubed, and then if we multiply this fraction, we're going to have x4 plus 81, and then we divide this by x to the power of 4. And if we multiply this by the x cubed, what are we going to have? X to the power of 4 plus 81, and then these will cancel out, so we'll have x cubed divided by x to the power of 4. That is going to leave us with 1 over x. So therefore we have x to the power of 4 plus 81 over x. Then we can substitute this back in. So therefore we have that dy divided by dx is going to be equal to negative 18. And then we divide this by our expression here, which is x4 plus 81. Then we divide that by x. So you think, what can we do now? Well, we can take this fraction at the bottom and multiply everything by x. What's that going to leave us with? That is going to leave us with 18x, and then this x will disappear. So therefore, we can conclude this will be our final answer. We're going to have that dy by dx is going to be equal to negative 18 multiplied by x, and then we're going to divide by x to the power of 4 plus 81. And therefore, we've completed the question, as this was what the question asked us to find. We're writing as required, as this is what the question asked us for. So taking a look back, this question was worth 4 marks. So we receive 1 mark for attempting to differentiate, and then we receive our 2nd mark for having the correct differentiation. So we receive, we'll just write our 2 marks in here, and we'll just annotate this. We get 1 for attempting differentiation, and then we get 1 mark for correct differentiation. So that's 2 marks there. We then receive our 3rd mark for correctly using the trig identities and getting ourselves to an expression for dy by dx. So that was at this point here that we received this mark, and then we receive our 4th and final mark for then manipulating this expression and getting to the required answer, which the question asked for. So that's at that point there we receive our 4th mark. So in part B, we're asked to prove that the curve C has a point of inflection at x is equal to the 4th root of 27. So this is equal to, just to add in, this is going to be equal to 27 to the power of 1 over 4. As we don't normally see the kind of the 4th root of something, we normally deal with the cubed and the squared root, but this is the 4th root. So we know from part A that we have an expression for dy by dx, and that is negative 18x over x to the power of 4 plus 81. And what do we need to do here? So we're asked to prove this here is a point of inflection. So what does this involve? So what we want to do is differentiate again to find the 2nd derivative. And then we can substitute in various values because we know that a point of inflection will look a bit like this. So it could be like that. So we can see that if this is the kind of stationary point, if you like, here, it's going to be negative on one side and positive on the other. So what we can do is we can find the 2nd derivative and then substitute in the point we're given. So that's this point here. And then we can also substitute in a point slightly greater than it and a point slightly less than it. And if they are respectively greater than, equal to, and less than 0, we can then work from that and see if we do have a point of inflection. So the first stage is going to be to differentiate. So we're going to use the quotient rule. This is because we have a fraction to differentiate. So what will we do? So we have negative 18x, that is going to be our h of x, and then our g of x is going to be x to the power of 4 plus 81. So we're going to differentiate these. This time we just differentiate normally, no implicit differentiation required. We have that negative 18x will differentiate to negative 18, and x to the power of 4 plus 81. We know 81 will differentiate to nothing, and x to the power of 4 is going to differentiate to 4x because we multiply by the power, and then we take 1 away from the power, so that's 4x cubed. So therefore, we can say that d squared y divided by dx squared, so our second derivative, is going to be equal to, so we're going to have the derivative of the numerator, so negative 18, we multiply it by x to the power of 4, we add on 81, and then we're going to subtract the other derivative, so we're going to have 4x cubed, and we're going to multiply that by negative 18x. And then what we're going to do is we're going to divide everything by x to the power of 4 plus 81, and then we square that bottom term. So therefore, continuing this working on, we'll simplify this. So we're going to have just multiplying out the numerator, negative 18x to the power of 4. Then we're going to subtract negative 18 multiplied by 81, which is negative 1,458. And then we're going to now add on, because we have two negatives, we're going to add on 4 multiplied by 18, which is going to be 72. And then we have x cubed multiplied by x, which is equal to x to the power of 4. And then our denominator stays the same, so it's going to be x to the power of 4 plus 81, and we're going to square that. So we can simplify this a little bit further. So we're going to have 72 minus 18, which is equal to 54x, and it's going to be to the power of 4, and then we're going to subtract 1,458, and then we're going to divide everything by x4 plus 81, and that's all to the power of 2. And then what we can do, we can take out a common factor of 54 to get our x to the power of 4 term on its own. So that's going to be 54 lots of x4. Then we take away 1,458 divided by 54, which is 27. And then we divide this by the denominator, which is the same. So it's going to be x to the power of 4 plus 81. And we square this. So effectively, this is our expression for d squared y by dx squared. So this is the second derivative of our function. So what we're going to do is we're going to take this function and then we're going to substitute our values into it to then see what this point is. Is it going to be a point of inflection? So we've just copied down our equation once again there. So this is our second derivative of our function. So then we'll say x equal to the fourth root of 27, we could then substitute this in. But what do we notice? If we take both sides to the power of 4, we have x to the power of 4, and then we just have 27. But we can see here that we have x to the power of 4 terms in our equation. So therefore, we can say that x to the power of 4 is equal to 27. So therefore, we can substitute this into the second derivative. So therefore, for x to the power of 4 equal to 27, we'll have that d squared y divided by dx squared is going to be equal to, so we'll have 54, then we'll have 27 minus 27, since we're substituting in 27, and we'll divide that by 27 plus 81, and we'll square all of this, and we put this into our calculator, and we see that this is equal to 0. So then what we can now do is we can take a point which is slightly greater than x to the power of 4 is equal to 27, and we'll substitute this in as well. So we'll say that for x to the power of 4 greater than 27, well, we can see here that our numerator is always going to be positive because we're going to have a number which is greater than 27. So this term here will always be positive, and we know that this is being squared, so this can never be negative. So therefore, we'll have that d squared y by dx squared is always going to be greater than 0. So then we can also say that for x to the power of 4 less than 27, well, what's it going to be this time? We know that if we have something that's less than 27, this term here is going to be negative. This term on the bottom is being squared, so the denominator is always going to be positive. But yeah, we can then see that this, because anything less than 27 is going to leave this term being negative, we'll have the second derivative is going to be less than 0. So therefore, we can see that at this point, the value of the second derivative is 0. For anything greater than this, we have that the second derivative is greater than 0, and for anything less than x to the power of 4 is less than 27, then the second derivative will be less than 0. So therefore, from this, we can conclude that there's a point of inflection at x equals the fourth root of 27. So then taking a look back at this question, it was worth 3 marks, and we pick up our first mark for attempting to differentiate the expression we're given, and doing that by using the quotient rule. So we receive that mark just here. We then receive our second mark for having the correct simplified expression for the second derivative. So that was here when we got that the second derivative was equal to 54 lots of x to the power of 4 minus 27 divided by x to the power of 4 plus 81 squared. And then we receive our third and final mark for having the correct conclusion, which was that yes, this is a point of inflection, and having the evidence to back that up. So that was at this point here where we received this mark. We're being asked to prove by contradiction that there are no positive integers p and q such that 4p squared minus q squared is equal to 25. So we first think, proof by contradiction. What is proof by contradiction? What does this mean? So there is 3 steps that you kind of generally have to follow when you're solving a question like this, and I've listed them here. So you first want to assume that the first statement is false. So in our case, we will assume that there are positive integers p and q such that, etc. We'll come back and write that down in a second. Then our second step is then, through logical steps, arrive at a conclusion. And then finally, we can then, from that conclusion, deduce that the original statement must be true. So what are we going to say here? So like I briefly mentioned a second ago, we're going to say, let's assume that there are positive integers, p and q. So what I'm going to do here is I'm going to highlight the word r, because this is key, because this is what changes from when we have our statement that they give us there are no positive integers, and we now have that there are positive integers p and q. And then we're going to say such that 4p squared minus q squared is equal to 25. So what we're going to do is we're going to work with this expression here and try and solve it. So we'll just copy that down. We have 4p squared minus q squared, and that's equal to 25. So we can see here we have 2 terms which are squares. So then if we do the difference of 2 squares, this is going to leave us with 2p plus q in one bracket, and then 2p minus q in the other bracket, and this is still equal to 25. So just to double check, we know that if we multiply out these brackets, we'll get back to this here. So that's all good. So we now need to think, what do we do next? So we know that if this is going to be true, then we can look at the factors of 25, and then we know that these brackets are each going to equal one of the factors. So therefore, if we take 25, we'll just write it down here, what can we multiply together to get to 25? And this is going to be integers only, so we know that we have 1 multiplied by 25 is going to be equal to 25. And then the next thing we have, we're not going to have 2, 3 doesn't go to 25, nor does 4. So we have that 5 times 5 is going to be equal to 25. So therefore, our factors of 5 are going to be 1 and 25. And we also have 5 and 5. So that's our factors. So what we're going to do now, so we're going to say, therefore, if what we've said is true, so if true, then we know that 2p plus q, and we're going to take a look at the 5's first, because we know that we don't need to do it twice because we have 5 and 5, so we know that either way 2p plus q is going to equal 5, and then also 2p minus q is going to equal 5. So therefore, what we're going to do is we're going to now solve for p and q, and we have here 2 equations, both with 2 variables, p and q, and we can solve for these using simultaneous equations. So then we can rearrange this, and we can say that q is going to be equal to, well, our 5 stays there, and we subtract 2p, and then likewise we're going to have, on this side, we're going to solve for q. We're going to have that q is going to be equal to, well, we add q to both sides and subtract 5 from both sides. So that's going to be 2p minus 5. And then what we do now is we equate these. So therefore, we have that 5 minus 2p is going to be equal to 2p minus 5. So then rearranging this, we have that we're going to add 2p to both sides, and we're going to add 5 to both sides. So this is going to leave us with the fact that 4p is going to be equal to 10, and therefore we divide both sides by 4, and we have that p is going to be equal to, we can put this into our calculator to get in decimal form, p is going to be equal to 2.5. Therefore, we can use our value of p in this equation here to work out the value of q. So therefore, I have that q is going to be equal to 2 multiplied by 2.5, and then we're going to subtract 5. So we know that 2 multiplied by 2.5 is 5. 5 minus 5 is 0. So therefore, q is equal to 0. So we can just note here that p equals 2.5 is not an integer. And remember, in our proof, we've assumed that there are positive integers p and q, such that this is true. So you're looking at our first option, we can see that this is not going to be true so far because p is not an integer. So then moving into our next option, so we need to include the term or. So now we have or, if true, then we'll have that 2p plus q is going to be equal to, well, we're going to be looking at our 1 in 25 factors. So we'll begin with 2p plus q is equal to 25, and then this would mean that 2p minus q is equal to 1. So therefore, rearranging these in the same way, we have that q is equal to 25 minus 2p, and likewise, we'll have that q is equal to 2p minus 1. So therefore, equating these, we have that 25 minus 2p is going to be equal to 2p minus 1. Therefore, rearranging these, we'll have that 4p is equal to 26. So therefore, we put this into our calculator, 26 over 4, and we know that this gives us that p is going to be equal to 6.5. So again, this is not an integer. And we can then say that q is going to be equal to 2 lots of p, so 2 lots of 6.5 minus 1. What's that going to be? That's going to be 2 lots of 6.5, that's 13. We subtract 1, that is equal to 12. So therefore, we can see, again, this is not going to be an integer. So then we can also say, so or, if true, then we have, so this time we're going to have it the other way around. So when 2p plus q is equal to 1 and 2p minus q is equal to 25. So we'll have 2p plus q is equal to 1 and 2p minus q is equal to 25. So what's this going to mean? So we'll do exactly the same method again. So we'll have q is going to be equal to 1 minus 2p, and we'll have that q is equal to 2p minus 25. So then what we're going to do is we're going to do exactly the same, and we're going to equate these. So we'll have that 1 minus 2p is going to be equal to 2p minus 25. This actually works out the same as last time, and we have that p is equal to 6.5. Then the only difference here is we're then going to work out q. So we have that q is equal to 1 minus 2 lots of p, which is 6.5. Then this time, if we put this into our calculator, this comes out as 1 minus 13, which is negative 12. But we can say here that this is not going to be valid because A, this is not an integer, and B, Q is not positive. Because remember in the question, we're told that P and Q are positive, so Q is not positive. So therefore, all that we had to say was that this solution doesn't occur because P and Q aren't positive. But what we've shown is that there are no solutions that are integers. So we have P is equal to 2.5, P is equal to 6.5, and P is equal to 6.5. So really, this isn't possible, so we've reached a contradiction. So therefore, we can say that this is a contradiction as there are no integer solutions, hence there are no positive integers P and Q, such that 4p squared minus q squared is equal to 25. So therefore, taking a look back at this question, we see that it was worth 4 marks. So we receive our first mark for setting up the contradiction and factorising and getting to the stage where we had that 2p plus q multiplied by 2p minus q was equal to 25. So that's where we receive our first mark just there. And we then receive our second mark for getting to the first kind of if true statement. So at this stage here, when we said that if true, then 2p plus q is equal to 5 and 2p minus q is equal to 5. So we receive our second mark just about there. We then receive our third mark for getting to the first point where we had solutions. So that was either when we had the p equals 6.5 and q equals 12, or in our case, you get it for doing your first mark. So that was when we had here the p was equal to 2.5 and q was equal to 0. We then receive our fourth and final mark for our kind of concluding statement when we said that this is a contradiction as there are no integer solutions and hence there are no positive integers p and q such that 4p squared minus q squared is equal to 25. So we'll just put our fourth and final mark for this question in here. And therefore, we've completed this question.